In these problems, we are finding derivatives with the power rule, something called the power rule. So when you have a polynomial, you've got a variable to some power. This is a method for taking the derivative of that function. Before we jump into that, I actually want to show you something in GeoGebra. There's a pretty neat thing in GeoGebra where you can take the derivative of a function. There's a command to do that. And what I've done here is I've started out with this function. This is x to the fourth. Well, actually, it's 1/8 times x to the fourth. So we've got a fourth degree function here. When I take the derivative of that, I get this blue one. And that should look like a cubic function to you. And in fact, the derivative of 1/8 x to the fourth is 1/2 x to the third. And the derivative of 1/2 x to the third is this red line, which should look like a parabola or a quadratic. So we've got 3/2 x squared. And if I take the derivative of this parabola, I get a line, 3x. Now, what I want you to notice here is that every time you take the derivative of something, the power goes down by 1, and then something else happens with the constant on the outside, and we'll sort that out in a minute. But when you take a derivative, you reduce the power by 1, and that's the starting point for this. What I've got over here on the right is the power rule, and it can be a little confusing. There are a couple of different notations for a derivative. If you have a function f of x, then the derivative you could call f prime of x. So that's one notation. Another notation is what you see down here, this d dx notation. What this is saying is the derivative with respect to x of this function. So if you have x to some power, to get that derivative, first of all, you take that power and you multiply it out front. Then you subtract 1 from the power. So it's kind of a two-step thing. Let me show you how that works here. So first, I take the power and I multiply it by 10. So I've got 70. Then I write my variable, but I subtract 1 from the power. So the derivative of 10t to the 7th is 70t to the 6th. Let's try some more. Here you see one in that d dx, or in this case d dz uh, uh, notation. So we want the derivative of this function u with respect to z. And I've got 11 over z. I don't see a power there, but when the variable's on the bottom of a fraction and there's no other exponent, that's to the -1 power. So I could rewrite this as 11 times z to the -1. Now applying the power rule should be pretty easy. I just multiply by the power, so that's going to be a -11. And then I reduce the power by 1, so this goes from -1 to -2. Okay, let's do another one. Here we've got 4/7 times x to the -3. Again, I've got an exponent here. I just multiply, so that's going to give me -12/7. And then I reduce the power by 1, so a -3 becomes a -4. All right, a couple more. Here we've got a function that is u equals 5/7. There's no power here. There's not even a variable. So what are we doing? I would encourage you to think of this as this. Anything to the 0 power is 1. So a constant like this is really the constant times x to the 0 power. It's the same thing. And if you were going to derive this one using the power rule, you'd multiply by 0 out front. And then, well, it doesn't even matter what you do next. We could reduce that power by 1, but it's all multiplied by 0. So the answer is just 0. Always, the derivative of a constant is the number 0. And let's try this crazy looking thing. So when we have sort of radical signs and powers within the radical signs, you probably want to rewrite this as a fractional power. And the way a fractional power is going to work is that the root would be on the bottom and the power on the top. So if I wanted to rewrite this as a fraction, let's see, we've got 4, and then we've got x to the 3/4, power on the top, root on the bottom. Now deriving this should be pretty easy. We're going to multiply come on, pen. We're going to multiply by 4 by 3/4, and that's just going to be 3. And then we're going to subtract 1 from the power. So 3/4 minus 1 is -1/4. So that is a little bit of work with deriving with the power rule.